Hi everyone, my name is Meena and my business partners are Priyanka and Parvinder. We are all about hiking and our store specializes in tumblers for outdoor enthusiasts like us. Today we are diving into linear equation programming and sensitivity analysis with the goal of maximizing the profit. So let's go into the detail of our model first. We have two decision variables in our linear equation model: Stanley ice flow, which is represented as A, and Stanley quencher as 2O flow state, which is represented as B in this model. Next, we have five constraints in this model, and those are purchase constraints. They are the total stock we can purchase from suppliers. Storage constraint, it is the maximum number of tumblers we can store. Packaging constraint, this is our packaging capacity of the tumblers. Shipping capacity constraint, this is the maximum shipping capacity we have. And the sales target constraints, so this is our sales target that we aim to surpass. That is why we are using greater or equal to sign here. So the same problem that we have I just stated above is represented in the mathematical equation format over here and the table format over here, so that we can easily calculate later on. And so after running our calculations, our optimal solution for A is 820 units and B is 1020 units, and the maximum profit we have is 19,420. So this is the solution that we got from the solver. Here the right hand side shows the maximum or minimum allowable value for each constraints. It defines the boundary or limit within which the decision variables must operate, whereas the left hand side represents the actual value or expression involving decision variables in the optimization problem. So it is usually a combination of decision variables, coefficients and constants that describe the utilization or allocation of the resources. So the difference between the right hand side and the left hand side gives us this slack or surplus value, which you can see in the lingo solution as well. So 19,420 is the maximum profit, and 460 is the difference between the right hand side and left hand side for the purchase constraint, um, which means that the resources are not fully utilized. 460 means that the resources is not fully utilized and the constraint is not binding, and wherever you see zero, this means that the resources were fully utilized and the constraint is binding, and so on. So now let's visualize the solution graphically to understand the uh, problem. Uh, so here in the graph, you will see five lines because we have five constraints in our model, and each line represents the constraint, and the intersection here defines the feasible region where all the constraints are satisfied. Here, highlighted in gray is the feasible region with all the extreme points in our graph. So there are five extreme points, and the line where the intersection where the two line intersects. So this intersection point is the optimal solution that we have for for this model. So optimal solution for E is 820 and B is 1020, which we got from the our solver solution as well. And we have just calculated all the extreme points and the line of intersections in the chart here. So moving to the sensitivity report, uh, we have here for A and B, the reduced cost for both A and B variables is zero, which means that the increasing the quantity of any of the tumbler A or B by 1 unit from the optimal solution does not change the profit. And the shadow price here shows that for every 1 unit increase in the storage capacity, the profit would increase by 2.6 per tumbler, and for every 1 unit increase in the packaging, the profit would increase by 1.6 per tumbler. However, increasing the storage capacity would be more beneficial to us since the profit contribution per tumbler is higher compared to a packaging, that is $2.6 versus $1.6. Um, However, the increasing or decreasing the other constraints like purchase, shipping, and sales constraints would not impact the profit. This is because their shadow prices are zero as indicated here, and so we also need to check for like if we want to increase, then we need to check whether by what quantity that we can increase. So for storage we can increase up to 2050 and decrease by 1700, and for packaging we can increase by 425 and decrease by 1367. If we use the maximum allowable increase for the storage and packaging, then we can earn additional 6010 US dollar from this analysis. um, that's all. Thank you for listening, and we are hoping to get feedback for it.